Welcome to Teddy Talks. In this video, we are going to look at an example where we are going to consider motion of a connected particle. And the question reads that a mass of 9 kilograms resting on a smooth horizontal table is connected by a light string passing over a smooth pulley at an edge of the table. To the pulley is a 7 kilogram mass hanging freely. Find 1. The common acceleration. 2. The tension in the string. 3. The force on the pulley system if it is allowed to move freely. So I told you that the first thing we do is sketching. We begin by sketching. And when we are drawing these diagrams, be careful. You must make sure that the string is straight. The string should be straight. So they said a body of 9 kilograms. So this body is resting here. So we expect there to be tension in this string. Now, if it is allowed to move freely, it means that that is the direction of what? Of motion. Now, what do they want? They want acceleration. Acceleration is not no. Now, let us consider each body separately. For the 9 kg mass, what do we know? We know that this will be tension should be equal to 9A. We can call this one equation 1. And then for the 7 kilogram mass, we say that the 7 kilograms, which is the weight, whose weight is 7g, is going to pull the body downwards, then minus the tension should be equal to 7A. And this is equation 2. Now, looking at this, we have equation 1 and 2. We can add equation 1 and 2 to eliminate the tension. So we shall say equation 2 plus equation 1. Now when we are adding them, this collapses with that, and we are left with 7g is equal to 9a plus plus 7a, we get 16a, which tells us that a is equal to 7 times 9.81 out of 16. Therefore, the common acceleration, I get the calculator, means that our common acceleration here, this is 7 times 981 divided by 16, and it gives me my acceleration as 4.29 meters per second squared. Never forget the units. Those units are very vital. So Roman numeral 2, they said we should calculate the tension in the string. So how do we calculate tension? We use any of the expression. So we can say, maybe using equation 1. Equation 1 said that tension was equal to 9A. Therefore, our tension will be 9.429. So I come and say my answer times 9, and my tension here is 38.62 Newton. And I've calculated my tension as easily as that. Now they said we should find the force on the pulley system. And you remember, we said that the force that is on the pulley system is always the reaction of the forces that are acting there. So let us try to sketch. Let us look at the pulley. If this is the pulley, there is tension here, there is tension here. Now, for us to get the resultant force we see that it should be acting at right angles, and for us to be in position to get the resultant force, we use Pythagoras theorem, which shows that this is F squared plus T squared. Therefore, our resultant force is the square root of T squared plus T squared. Therefore, this will be equal to the tension, which is 38.6 2 squared plus 38.62 squared. Now, 38.62 squared is equal to that, plus 38.62 squared, then the square root of the answer. We are saying that the force that acts on the pulley system is 54.64 newtons. We shall have calculated as required. Okay?